Hello children, welcome to channel Sube. Children, today I am going to discuss question number 19 from the MCQ part of 2022-23 Physics New Syllabus paper. The figure shows the displacement s time t graphs of two objects P and Q moving along a straight line. Consider the following statements. Capital A, both objects have velocities in the same direction. Capital B, velocities of both objects increase with time. Capital C, both objects have the same velocity at the crossing point of the two graphs. Of the above statements, only A is true. Second one, only A and B are true. Third one, only A and C are true. Fourth one, only B and C are true. Fifth one, all A, B and C are true. Children, let us recall the knowledge needed to solve this problem. What we have to use here is the theorem that the gradient of a displacement time graph, displacement is here time t So the theorem of that the gradient of a displacement time graph is equal to the velocity. So suppose this one is the graph, say P. So the gradient, how to get the gradient of a certain point. Suppose the point is this one and this one. Let us take few points. To get the gradient, we have to draw a tangent like this to the point, to the graph at that point. To the graph at that point we have to draw a tangent. So we have to get the angle from the x-axis. X-axis means this one is the x-axis, so parallel to that x-axis we get the direction. So from that direction we have to get the angle. So suppose this one is theta 1, this one is theta 2, this one is theta 3. So what has happened to the gradient? Little by little increased. So the gradient is increased. So theta increased in a graph like this. So the theorem is this one. The theorem is this one. The gradient of a displacement time graph is equal to the velocity. So this theta equals velocity. So therefore now let us examine the gradients of the given graphs. This one, we can see that the gradient of the given graph for the motion of the object P increases gradually. So like this, the angle increases, so the gradient increases, so the velocity increases. So you have to get the angle like this from parallel to the x-axis. So the gradient, the theta increases. So therefore from the beginning to end, continuously it increases. So we can say that the velocity continues to increase. So the velocity of graph P increases. So that is correct, but here both objects have velocities in the same direction. We have to now check the direction also. Before that, let us try this B statement. B, velocities of both objects increases with the time. Both objects. Let us check now. So it is clear. The object, the velocity of this object P increases gradually. That is correct. So let us now check the velocity, the gradient of the graph q. So the gradient is like this at the beginning, and then at the middle the gradient is decreased like this. So furthermore it decreases, and here it is 0. It is level with the x-axis, so therefore there is no angle. So the velocity here is 0. Velocity here is 0. Here some value. So what happened? What has happened? Decreased, continuously decreased. So what they say, velocities of both objects increase. So it is correct for this object Q, object P, this one. For this one it is correct, but for this one, for Q, it is wrong because it decreases. Here what they say is increase with time. So this one is wrong. So now let us recall our knowledge about the direction of the velocity, direction of the gradient. So if the graph is like this, suppose the graph is like this, then the gradient is like this at the beginning and at the middle and at the closer to the end. So the gradient, let us examine the gradient at these points. What is gradient? The angle from the x-axis. So this one is the line parallel to the x-axis. So gradient is this one, theta, and also the tangent is tilted left, or leaned left, or skewed left. So therefore the gradient is minus, the sign of the gradient is minus. The gradient equals the angle, so angle equals velocity. So velocity is minus, therefore these types of graphs. So since the gradient is negative, hence the velocity also is negative. So here in this graph Q, what has happened? The gradient is not negative, it is still leaned or tilted to the right side, not to left side. Here it is negative if it is tilted to the left side, but here it is tilted or leaned to the right side. So both the graphs have gradients leaned to the right side. Therefore both the graphs have positive velocities, not negative velocities. That means not opposite, they are moving to the same direction. So let us discuss this one. Therefore both objects have velocities in the same direction. That is correct, because both the graphs have their tangents at all the points, they are tilted to the right side or lean to the right side. So therefore velocity is in sign positive. Positive means same direction, and also the magnitude increases along this one, but decreases along this one. So therefore the B statement, the magnitude is not increasing of both the graphs, and both objects have velocities in the same direction is correct. So the statement B is wrong, therefore, because velocities of both objects increase with time, but here decrease it decreases, therefore it is wrong, but the direction is same, therefore A is correct. So now let us go to this statement C. Both objects have the same velocity at the crossing point of the two graphs. So at the crossing point, what they say, both objects have the same velocity at the crossing point of the two objects. So let us check whether it is correct. So to be the velocities equal in magnitude, what should be there? The condition, the gradients should be same. So here the gradient is this one at the crossing point. So the crossing point is this one. So we have to get the gradient at that point. The tangent should be distributed at the both sides. The midpoint of the tangent should be at the time axis at that point. So the gradient of this graph Q is this one. So it is almost zero. It is almost level with the x-axis. So the gradient almost zero. So velocity here is almost zero, but velocity here is some big value, is something like 10 or something like that. We can't say the value, but it is not zero. So we can say it is not zero because the gradient is greater here. This angle is greater, therefore the velocity is greater. So what they say is same velocity, so that is wrong. Therefore not same velocity. Velocity of Q is 0, but the velocity of P is something not 0. So therefore the statement C is wrong. So now the correct answer is only A is correct, this one, the first one. So question number 19, let us check the answer sheet. Question number 19. Here the answer is 1, first one. So that is correct. This one is correct. Children, I have prepared a target question for you. Target question number 1. Now you have to solve this on your own, honestly, without looking at my answer. So pause the video now, then start it. Children, since you have paused the video, now I am going to start without wasting time. So the statement A, both objects have velocities in the same direction. Let us examine the direction. Direction of this one is positive because it is tilted to the right side. This one is the angle. So positive velocity. The gradient is tilted to the left side of this graph. So therefore it is a negative gradient and negative, therefore velocity. The velocity is negative. So that means opposite. So this one is moving to this direction. The red one is moving to positive direction. If we take positive direction as right side, positive direction assume this way. So the object P moving, the object P is moving to the right side. If the object P is moving to the right side, then the object Q is moving to the left side. So there is a minus velocity. The objects have velocities in the same direction, so wrong. It is wrong. Then statement B, velocities of both objects increase with time. increase with time. So this one increase, that is correct. That is correct, increase. But this one decrease. The angle decreases. The angle decreases. So angle is this from this x-axis. Like this, it decreases. So gradient is decreasing, the velocity is decreasing. So it is wrong for the object Q. Velocities of both objects, they say it is wrong, only it is correct for the increasing of object P. So this one is wrong. Both objects have the same speed at the crossing point of the two graphs. So the crossing point is here. So you can see the both graphs have the same angle but in opposite direction. Same angle, symmetric. So the angles are same, but the direction of this one is negative, since the direction of this one is positive, but the magnitudes are same. So regarding neglecting the direction, we can say the magnitudes of the angles are equal. Therefore the speed, we can say speed, we can't say velocity, because the directions are opposite but the magnitudes are equal. So therefore we have to say speed. Both objects have the same speed at the crossing point of the two graphs. So that is correct. This one was wrong, this one was wrong. So the final one, the C, only correct. Only C is true. The answer is 3. Children, here is your next target question. Question number 2. Try to solve this on your own without looking at my answer. Now pause the video, do it honestly. So since you have paused the video, I am going to solve it. I am going to start it. Regarding this statement A, both objects have velocities in the same direction. So this one has a velocity positive, always positive, tilted, the tangent tilted to the right side, therefore positive direction always. But here at the beginning, the velocity of object Q is negative because it is tilted left side like this, negative velocity. So this statement is therefore wrong. Both objects have velocities in the same direction. Wrong, because at the beginning this object Q has opposite velocity relative to the object P. So therefore it is wrong. Now let us go to this one, B. Velocities of both objects increases with time. Increases. So this one is increasing, that is correct. But here it is decreasing again. Increased, no. Here this one, increasing, and this one decreasing again. At this part it is decreasing, increasing and decreasing. Here of the object Q, it is decreasing, the angle is decreasing. So after that increasing and again decreasing. So therefore we can't say velocities of both objects increase with time. We can't say it is changing, it is varying. So this one is wrong. Both objects have the same velocity at the crossing point of the two graphs. The crossing point is this one at this place. So both have same gradients. Both have same gradients. This one and also this one. So that means the magnitudes of the velocities are equal, as well as the direction is equal. Both objects have the same, therefore we can say velocity, not the speed, velocity we can say, because the direction also is equal. Directions are also equal. Same velocity at the crossing point of the two, that is correct. Only C is true. The fourth one is the answer for this question. So children, now I am going to wind up the video, because now we have spent enough time. So children, I think you are happy, because I explained you and created and typesetting. I did all the typesetting and everything, and I discussed altogether 3 questions, 2 target questions like this. So I think you are happy. So if you are happy, what you have to do, make me happy too by subscribing my channel if you haven't already done it. Then share my link among your friends, and press the thumb up button, and also press the bell icon. So thank you very much for those watching my videos, and thank you very much for those subscribe to my channel. So children, see you tomorrow at 6 o'clock in the evening. Goodbye children.